Hello, Algebra 2 students. For Ms. Bell, we're looking at the system of linear inequalities exploration. You guys were working on this in class. In case you missed this, I want to go through it. And then I think maybe the back you did for homework. We'll see. I have a couple of those done and I'll explain them. So for number one, use one of your colored pencils, graph the inequality below on the coordinate plane. And I did this one in red. So you just go to the y-intercept -1. So I started at -1 right here. And then I went up 3 over 1. Remember, if it's just a 3 there, it's up 3 over 1. So I went from -1 and I went up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Okay, and this is supposed to be a dotted line. So because it is not equal to, it has to be y, it has to be less than that. So this is a dotted line. So I traced it, and I didn't really dot it, but hopefully you understand that that's a dotted line. And so y is less than it. So the y values, so let's go back to the y-intercept. The y values that are less than are going to be below, so down. So anything below this line, okay? Even though it's pretty steep, everything below it, okay? So describe the solutions to the inequality you graphed. Are the solutions above or below the line? You would put below here. You would write below there. Okay, so for number 3, name 2 possible solutions on the inequality you graphed in number 1. And I just randomly picked these two, 2, 0. 2, 0 would be right here, and 6, -6. That's before I put the green on there. You could easily see that those are solutions to this equation right here. Now let's talk about using your the green one. I had to do number 4, even though I said I'm just doing the odds. I had to do number 4 in order to answer number 5. So in green, use your other colored pencil, graph the inequality below on the same coordinate plane. So this is in green. And you'll see that I went to the +5 y-intercept. And then I'm going down 3 over 1. Remember, if you just see a whole number here, you just put it over 1. So you got your rise over your 1. In this instance, it's not rising, it's declining. So from here, it goes down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1, and so on. Okay? And then I just graph that. That's a solid line because it can equal what is on that line. And y is greater than, so it's above. You shade everything above that line. So describe the solutions, anything above the line, including the line too, including that line y equals -3x plus 5. So name 2 possible solutions. So anything in the graph, the shaded area for green, I mean, you could pick this one. This is 1, 8. You could pick something that covers both of them. 6, 4, any points. There's a couple for you right there though. Number 7, use a marker or a dark colored pen, pencil. Outline the area that you believe the solution set. I actually shaded it in pencil and describe it and explain why you chose this area. So both areas are covered where it's gray. Okay, so you just shade that in. And my explanation, it includes solutions from both the inequalities, this and this. Okay, that's why. That's the solution set area. Name 1 solution to the system of inequalities you graphed above. Show why algebraically you think this point is a solution. So let's just take one point here. Let's take this point right here where it's 4, 0. 4, 0. So if I were to do this algebraically, so I picked 4, 0, right? So my y, let's plug this into this one. 0, 3 times 4 minus 1. 0 is going to be less than. This is 12 minus 1, which is 11. Is that true? Yes, it's true. So let's take a look at this one. I'm going to use this one right here. So y is 0. negative 3 times 4 plus 5. 0 is going to be greater than or equal to, I have negative 12 plus 5, which is going to give me negative 7. 0 is greater than negative 7. Okay? Think of these cold temperatures around right now. 0 is actually warmer than negative 7 degrees, So, sounds cold still, but it's greater. Okay, so it works. So that's an explanation of it algebraically. 9, based on your observations, explain how to solve the systems of linear inequalities by graphing. Graph each, and then you shade each, and the solution will be where the shaded regions overlap. If you want to pause that. Okay, taking a look at the back here. The border. What's the border going to be like for less than or greater than? It's just going to be dotted line. What's the border going to be like when you have that? It could be equal. It's going to be solid. Your shading. When you have less than or equal to, it's going to be below. And when you have greater than or equal to, it's going to be above. And the solutions are where the shaded regions overlap. Okay, pause those. So this first one, you could see where I rewrote. Sometimes you have to rewrite the equations, and I did the red one. I had to rewrite this one so that you want to make it look like y equals mx plus b, right? So you can graph it. So I have y is less than negative 3x plus 2, and the green one was fine the way it was. I graphed them. I went to the y-intercept plus 2, and then I went down 3 over 1, down 3 over 1, down 3 over 1, dotted lined it, and y was less than it, so everything below that red dotted line was shaded. So the green one, I had y equals just 1x minus 1, so I went to minus 1. And remember, if you don't have a number there, I just have a 1x, so remember that's going to be like 1 over 1. So the rise over run is going to be 1 over 1, 1 over 1, 1 over 1, 1 over 1. And so I just connect those dots. That's going to be a solid line. And then everything, y is greater than that, so everything's shaded above it. So which of these points are going to be in this section that's shaded by both the red and the green? 0, 0 is there. And negative 3, 3. Negative 3, 3 is there right in the middle of it. The other two are not there. You notice 1, 4. 1, 4 is only in green. 0, negative 4 is only in red. Try number 2 on your own. Number 3. I had to change the first one, and I made it my red to this, just algebraically, to make it look like y equals mx plus b. And the green one, I just had to move this negative 4x over to the other side of the inequality. I had to add a 4x to both sides. So these graph like this. So notice my red, my y-intercept was positive 1, and then I went up 3 over 2, up 3 over 2, and so on. Connect the dots, solid line. This one's going to be a dotted line. I went to positive 3, and it's 4 over 1. So I couldn't go 4 over 1 here, so I went back 1, and so 4 over 1, the previous point, and 4 over 1, the previous point, so I could get some reference on how to draw my line. Shaded both regions. This small little slice of pie up here is where they are, you're going to find your solution set. So the only one that works is 2, 4. So 2, 1, 2, 1, 2, 3, 4. It's on the line. So it's on that line. Guess what? It's going to include it. It can't equal it. So in the red, so we're good to go with 2, 4. The one that was close, let me see, 0, 3. 1, 2, 3. This one. It's on the dotted line. See, they're trying to see if you understand. The dotted line, no, it has to be less than it. It can't be on the line. So it has to be below that dotted line. So that's why 0, 3 doesn't work. Okay, good luck with number 4. And if you need any other help, please let me know.